How do you access the special registers such as PSP and MSP from your C code? We should be writing the inline assembly code, and the instructions what we should be using is MRS and MSR. Let's use this instruction in order to modify the value of PSP. Go back to the code. This is a thread mode code. We should be using PSP. But what is the PSP value? First, let's calculate that. Let's use some C macros. Hash define. What is SRAM start? SRAM start is 0 cross 2 0 0 0 0 0 0 0. Let me use this as unsigned numbers. I am going to use the character U here to mark this as, to tell the compiler that consider this number as unsigned int. Then what is the size of SRAM? So that is 128K, isn't it? SRAM end is SRAM start plus SRAM size. Let me keep this operands in separate parentheses. After that, what is stack start? Stack start is SRAM end. I can directly use this. Let's define these macros. Stack MSP start. Stack MSP start is nothing but stack start. And stack MSP end is stack start plus pi 12. I'm going to use this as stack MSP start plus pi 12. That would be good. After that, stack PSP start is nothing but stack MSP end. Let me write an inline assembly code. Here, when we enter main, let's change SP to PSP. Let me call this function. The first step what we're going to do in main is change SP to PSP, and I'm going to implement that as a naked function because we just want to use some assembly instructions. That's my goal. I cannot write it as a C function. I'm going to use attribute void change SP to PSP. First, let's initialize the PSP. ASM volatile. What is the instruction? MSR. Syntax is special reg you have to mention first. PSP and the register RN. I'm going to use R0. But what is the value of R0? R0 is not initialized. Let's initialize. ASM volatile LDR R0 equal to, let's initialize that with PSP start. That's great. PSP is initialized now. After that, use the control register to change the SP to PSP. It is right here. Control register is another special register of the processor. So this is also not memory mapped register. So it doesn't have any address. That's the reason we have to again use inline assembly code to access this register. In this register, you have to change the first bit position. You have to make it as 1. PSP is the current stack pointer. It defines the currently active stack pointer. We have to make it as PSP. Let's do that. I'm going to again use ASM volatile. I'm just going to use move instruction here because see, I cannot use move instruction here because this is a 32-bit value. If you want to use move instruction, then the immediate value has to be 16-bit. Here I can use just immediate value of 0 cross 02. because I'm going to set the first bit. And after that, ASM, volatile, MSR, control or not. That's it. This code is going to first initialize PSP and then change the SP to PSP. After that, let's write one more function called generate exception. We will cause some exception. Let me implement that function. Void generate exception. I'm going to use SVC instruction to trigger the SVC exception. If you don't know about SVC exception, then don't worry. It is one of the exception of the ARM Cortex-MX processor. We are going to cover that later in the separate section. SVC instruction can be executed by the thread mode code in order to get some services from the kernel level code. It is basically used in an OS environment where your application involves separate kernel code and user code. SVC is the instruction which is used to implement the system call layer. We'll see that later. We'll understand the syntax and other things later. But for a time being, let me use this SVC instruction with an immediate value of, let's say, any value between 0 to 255. When thread mode code executes this, SVC exception will be triggered in the processor and the SVC exception handler will be called. Let's write the SVC handler. The name of the handler you can get from here, SVC handler. Let's go back to the main.c and let's implement somewhere here. SVC handler in SVC handler. Let me just debug this code. We have a problem here. I think I cannot use the C macro in an assembly instruction. I think that is not allowed. No problem. We can do one more trick here. Instead of using C pre-processing macros, we can use equal assembler directive. This is a syntax. You have to use the assembler directive EQU followed by the label, comma, the value. So it is just like a similar way of creating macros. Let's use that. So I'm going to write ASM volatile EQU. Let me give the label SRAM end. First, let's calculate the SRAM end, which is nothing but, let's open the parenthesis, 0 cross 2 0 0 0 0 0 0 0 plus 128 in 2024. This is the SRAM end. According to our calculation, what is PSP start? PSP start is SRAM end minus 512. That's it. After that, use PSP start here. All these are not required. That's it. I'm going to compile this. There is some problem. Here is a problem. I didn't close this. I have to close this parenthesis. Now it looks good. Fine. Let's test this. Here we call change SP to PSP in the main function. So the control reaches here. And we should go back to the main function. That's why we have to now use the return instruction. The return instruction is BXLR. BX stands for branch indirect. When we jump from here to here, the LR is the register which captures the return address. LR knows where to go back when this function finishes. That's why we have to use LR here. The content of the LR will be copied to the PC, which is nothing but the return address. That's how control comes back to the main function from change SP to PSP function. And let's debug. Let's do single stepping and open the disassembly, or I can open the registers. Here first load R0 and here it is. The value of R0 is something like this. This is our start of stack for thread mode code. After that, that value is getting placed into PSP. You can see that PSP value is also modified here. PSP carries this value. After that, we are going to switch SP to PSP. What is SP? SP is still pointing to the MSP, remember that. Now we do a switch. Here it is, SP value got changed. So now PSP is used as SP. That's the reason why PSP value is copied into SP here. You are returning back to the main. Let's execute this instruction and you reach main. SP value is still same, no change. And after that, generates an exception. This code actually generates an exception. Let's do that. Let me execute SVC instruction and observe this SP. Execute this and here it is. SP value is now changed to MSP. Because handler mode code always uses MSP. That's why the processor does that change automatically. When you leave this handler and you go back to the thread mode, again SP will start using PSP. You can see that. So here it is. SP is now started using PSP. That's a demonstration of using PSP in thread mode and MSP in handler mode and changing the default stack pointer from MSP to PSP. As I said, most of the standalone code doesn't need this switching. It's not at all required. You can do everything using MSP, need not to switch to PSP. But for some OS designs or when the application is involved with kernel code and thread mode code, then the OS design uses such techniques. So now let me conclude this lecture with summary. Let's have the summary of MSP and PSP. Remember that physically there are two stack pointer registers in Cortex-M processors. First one is main stack pointer called as MSP. This is a default stack pointer used after reset and is used for all exception interrupt handlers and for codes which run in thread mode. And we have one more stack pointer called process stack pointer PSP. This is an alternate stack pointer that can only be used in thread mode. It is usually used for application tasks in embedded systems and embedded OS. Remember that after power up, the processor automatically initializes the MSP by reading the first location of the vector table. And about changing SP to access MSP and PSP in assembly code, you can use the MSR and MRS instructions. Never write C program, a pure C program, to change the value of PSP and MSP and to make a switch. You have to use naked functions, remember. In a C program, you can write a naked function that is a C-like assembly function which doesn't have epilogue and prologue sequences to change the currently selected stack pointer. In the next lecture, I'm going to cover function call and WPCS standard. I will see you in the next lecture.